Cambridge International AS Physics Paper 2, May June 2024. Paper 21 is the paper that I'm going to discuss in this video. So are you prepared? Now let us get started. First question, the drag force Fd acting on an object falling through air is given by Fd is equal to half C rho AV square, where A is the cross-sectional area of the object, V is the velocity of the object, rho is the density of the air, C is a constant, which we call it as drag coefficient. A, use SI-based units to show that the drag coefficient has no units. Do you still remember your 6 base units that you are required to memorize in your AS syllabus? Let me write down all the 6 base units. First one is the unit of mass, which is kilogram. SI units of mass. The second one is Kelvin, which is SI base units of temperature. Third one is meter, which is the SI base unit of length. Then ampere, which is the SI base unit of current. Second, which is the SI base unit of time. And the number of mole, which is the unit of amount of the substance. All these 6 base units are required to be memorized in your syllabus. Now, to prove that drag coefficient, which is C, has no units, I would like to use homogeneous equation. So since the equation is valid and left-hand side base units must be equal to right-hand side units, right? To prove that this equation is actually homogeneous, so all you need to do after that is just to cancel off the units to see whether C has no units or C has units. Now, first of all, my left-hand side, I have force. Right? So force or drag force, it doesn't matter whether it's a drag force, impulsive force, resistive force, or whatever drag force, right? The unit of force is the same, which is Newton. And how do we express drag force in terms of SI base unit? Altogether, you need to break down into a simpler manner. So I remember force as F equals to MA. F ma. So M is the mass, which SI unit is kilogram. A is ms -2. So kilogram ms -2, that is the SI base units of force, which is on the left-hand side. And what about rho? Rho is the density. Density is defined as mass per volume. The SI base unit of mass is kilogram. SI base unit of volume is meter cube. So you get kilogram per meter cube. And V is the velocity. Velocity, the SI base unit is meter per second. Now, since we get all the SI base units, so all we need to do is just to arrange them. Left-hand side, I have kilogram ms -2. Right-hand side, half is just a number. You can just ignore that number because number has no unit. This is C, the one that I need to prove that has no units. Rho is kilogram per meter cube. A is meter square because it is the area. Area is length times length, meter square. V square is meter per second, but you have to square it. Now I simplify. Kilogram meter per second square is equal to C. This is still kilogram per meter cube. This is still meter square. This is square. This is meter square as -2. Now I put M together. This is just kilogram. This is meter -3. And you need to remember when you multiply, you need to add out the power. So +2 and times with S -2. And then after that, just make things simpler. Kilogram mean ms -2 is equal to C. This is kilogram. M -3 plus 2 plus 2. 4 minus 3, that is 1, or M as -2. Could you see that left-hand side unit is equal to right-hand side units? I put C is equal to kilogram ms -2 divided by kilogram ms -2. So you get 1. That is why C has no units. To prove a certain physical quantity that has no unit, you need to prove that eventually you get 1 as your final answer. Now we continue with B. Fig 1.1 shows a sphere falling at terminal velocity in air. Assume that the upthrust on the sphere is negligible. Upthrust is the buoyant force. On Fig 1.1, draw and label arrows, more than one arrow, to show the directions of the two forces acting on the sphere. Since part A, they already give us a drag force, you need to include that drag force into this diagram, Fig 1.1. First, sphere falling. Any falling object is due to its weight, gravitational force acting on it. Gravitational force or the weight of the sphere acts at the center of the sphere, which is straight downwards, pulling it down. So this is the weight of the sphere. You just write down weight. The other one is drag force acting on moving object. You can just put FD, no problem, because they have already explained the symbol. C, the mass of the sphere is 49 grams. Calculate the drag force Fd acting on the sphere. Since the sphere falls with terminal velocity, could you see here? This is a keyword, falling at terminal velocity. Terminal velocity meaning to say that the resultant force acting on the sphere is equal to 0. That also means that the two forces balance each other. I would say that drag force is equal to weight. Weight is equal to mg. Mass is 49, but this is gram. You have to change it to kilogram. That is why I need to divide it to 1,000. And G is 9.81. Therefore, your drag force is 0.48 Newton. 0.48 Newton is the answer. D, the sphere is falling in air at a terminal velocity of 25 in SI base units. Density of the air is 1.2 in SI base units. Diameter of the sphere is 0.060 in SI base units. So you don't have to worry. Everything is in SI base units. Use your answer in C to calculate the drag coefficient C of the sphere. When you are asked to calculate the drag coefficient C, you have to use the equation that they gave you initially. Fd is equal to half C rho A V square. Now let me rewrite that. Fd is equal to half C rho A V square. Am I right? C rho A V square. Yes, it is correct. So I make C as a subject. To make C as a subject, I have C on the left-hand side, which is equal to 2FD over rho A V square. And all I need to do is just to sub in whatever information that I have to calculate the value of C. 2FD is 0.48, the one that I calculated earlier, divided by rho is the density of the air, which is 1.2. A is the problem now, but don't worry, because A of the sphere, right? The area of the sphere is pi r square, which is equal to pi r d. Diameter is 0.06. R would be 0.06 divided by 2, but you square the whole thing. Right, sub into the equation, 0.06 divided by 2, this is pi 0.03 square. Sub into the equation, you have pi times 0.03, you square it, and then times a v, which is 25, you have to square v. And when you do your calculation, you should be able to get 0.45. 0.45 is the answer without the unit. The next one, define velocity. Now, to define velocity, velocity is actually the change in displacement per time, or change in displacement per divided by time. B, a student throws a ball over a vertical wall of height h as shown in Fig 2.1. The ball leaves the hand of the student at a height of 1.2 meter above the horizontal ground. The ball has an initial velocity of 22 meters per second at an angle of 40 degrees to the horizontal. The wall is a horizontal distance of 36 meters from where the student releases the ball. Air resistance is negligible. Thank goodness to that. First part, determine the time taken for the ball to reach the wall. Now, since this is 2 marks given, it wouldn't be that hard. So how do you do about that? I try my best not to resolve because this is projectile motion. Projectile motion is a curved motion which you can resolve it into vertical and horizontal direction. I try my best not to resolve into vertical direction because it will be more complicated as compared to horizontal direction. In this case, since the horizontal distance or the range of the ball is being given, so I need to just use the range to find the time taken. So how do I do about it? I put horizontal, resolve, horizontally, or in x direction, right? So I put sx is equal to uxt. X means horizontal. Now I will redraw the one that is given here. This is 40. 40 to the horizontal. This is 40 degrees. And this is 22 meter per second. I want to resolve my initial velocity, but to x direction. So how do I do about it? This is sx. So I use cos theta. Cos 40 is equal to sx over 22. Therefore, sx is equal to 22 cos 40 degrees. Sub into the equation. 36 is the horizontal distance. 22 cos 40 times t. Therefore, t is equal to 2.14 second. 2.14 second is the answer. The next one, calculate the vertical component u of the initial velocity of the ball. Since I redraw this back, I have 22 meter per second acting here, and this is my 40 degrees, and I have to calculate this is vertical component of the initial velocity of the ball. So you use sine theta. Sine 40 is equal to uy over 22. Therefore, uy or u in this case is 22 sine 40 degrees, which gives you 14.1 meter per second. 14.1 is the answer. Now the third part may be a little bit challenging because the ball just goes over the wall. Calculate the height of the wall. Wow, goes over the wall. Now you see that the ball is being thrown at a certain height already. It's not from the ground. So which make things more complicated. You know what I'm going to do is that since the height from the ground to where the ball is being displaced is given as 1.2. This is 1.2. I have this height. And I do not have the one that I label with SY. To find H, I need the height that I have, which is 1.2 meter plus SY. So what am I going to do is that I find SY first. How do I find SY? I want you to have a closely look at this. So the ball, this is the where the ball lands, which is same height as where the ball is being thrown. So this parabolic motion, it is symmetrical. So this is, I need to find this Vy, the speed at that point, in order for me to find my Sy. So how do I do is that I'm using this equation. Vy, I resolve into y direction. Vy is equal to u plus gt, uy plus gt. So Vy, I need to find, uy is 14.1. And for this type, parabolic, yeah, symmetrical projectile motion, the g is always negative. So I replace it with 9.81 times the t time taken to reach the same height again. And Vy I got it was negative 6.89 meter per second, which is also true because V represents velocity and this Vy is in the direction of going downwards. So that is why it would take a negative direction. Since I have the value of Vy to find Sy, it will be even simpler. Which equation that I use to find Sy? I use Vy square is equal to Uy square plus 2G Sy. right? Vy is negative 6.89, but it's okay because when you square it, you still get positive value. Uy is 14.1, you square it, plus 2g, remember, it is negative. Sy, right? So Sy, you rearrange Sy, you should be able to get 7.7 meter. Therefore, the height h is equal to 7.7 meter plus 1.2 meter. The answer is 8.9 meter. Question number 3A, state the principle of conservation of momentum, right? So principle of conservation of momentum states that the total momentum in a closed system, I will explain what is meant by closed system, is always constant. A closed system means that, before I explain the closed system, let me explain about momentum. Momentum, you know, momentum is a moving mass. As long as the mass is moving, the mass has momentum. But closed, you know, when a moving mass, you know, whenever you're moving, like let's say I am moving, I'm running, I'm walking, I will still experience frictional force between my shoes and the ground, surface of the ground, or air resistance. Because I'm running, then the air resistance will be more significant acting on me. But to calculate, to use the principle of conservation of momentum, we ignore all the resistive forces that could be acting on a moving system, like resistive forces, like frictional forces, like air resistance, drag force, etc. All these we ignore to make our life, right, easier, to make our calculation simpler. So that is why you have to put in the closed system, right? B. An object of mass 2 meter is traveling at a speed of 5 meter per second in a straight line. It collides with an object of mass 3m, which is initially stationary, as shown in Fig 3.1. After the collision, the object of mass 2m moves with a velocity v at an angle of 30 degrees to its original direction, which is horizontal. The object of mass 3m moves with a velocity w, also at an angle of 30 degrees, as shown in Fig 3.2. Now, by considering the conservation of momentum in 2 dimensions, calculate the magnitudes of V and W. Look at the marks given. It is 4 marks. Very demotivating, don't you think so? But it is worth, right? So how do I do? So since they already give you the clue. You have to conserve, you have to resolve the momentum into 2 dimensions, X and Y directions, right, to calculate your V and your W. Now, I will resolve it into X direction first. X direction. For X direction, there is the mass, which is 2m, is moving with 5 meter per second. And oh, remember, momentum is a vector quantity, so I will consider to the right as positive. Now, 2m is moving to the right, so it is positive. Mu, so 2 times 2m times 5 is equal to, let us look at what happens next here. Look at this 2m. It is in this direction, and I can resolve it into horizontal direction, which is towards right. So to resolve it into horizontal direction, this is adjacent. So cos 30 is equal to V over Vx. This is Vx. Now, okay, V is equal to, no, I'm sorry. So it is Vx over V. Adjacent, Vx, Vx of 2m, yeah? I put V2m, is that okay? Because this is V, just Vx. Okay, Vx will do. Because this is V, the other one is W. So I just put here as Vx. Vx over V. Now, Vx is equal to V cos 30. I got my final velocity of mass 2m. And what about mass 3m? I will use different color for mass 3m. Mass 3m is moving downwards while going to the right. So you can resolve it in right direction as well. So this is Wx direction. I use adjacent. Cos 30 is equal to Wx adjacent over W. Wx is equal to W cos 30. That's it. Now put it, everything else will be positive because all the direction of 2m and 3m are in the direction of right side. So they will take positive direction. I put 2m, mass times velocity, remember? V cos 30 plus 3m, W cos 30. What shall I do now? Cancel all the masses. I have 10 equal to 1.732 V plus 2.598 W. I put that as first equation. Now, after that, I would like to resolve it into y direction. To resolve it into y direction, I look at the initial velocity of mass 2m because mass 3m is not moving. It is moving in horizontal direction. So the vertical initial momentum is equal to 0 because I cannot resolve it into vertical direction. And after that, what happens? Okay, after that, I want you to look at this 2m. 2m v is upwards. 3m w is downwards. So since momentum is a vector quantity, I'll consider upward as positive, downwards as negative. I'll do it right here. So this one, I will use sine 30. This is Vy is equal to Vy over V. Vy is equal to V sine 30. Done. And what about W? Sine 30 is equal to, this is negative Wy. Negative Wy over W. That is why Wy is equal to negative W sine 30. And I'm done with that. Now, let us form an equation in y direction. So I have 2m v sine 30 minus 3m w sine 30. And I move this negative to the right-hand side, and I have 2mv, right? Okay, this is sine 30. Okay, is equal to 1 over 2. So I move 3m. 3m w sine 30 is equal to 2m v sine 30. Now m and m you can just cancel off. Sine 30 is half or 1 over 2. So times 3. Here I got 1.5 W is equal to just V. So second equation is here. I will sub in my V into equation 1. So 2 into the first equation. So the first equation you modify becomes 10 is equal to 1.732. This is 1.5 W plus 2.598 W. Make W as the subject. You should be able to get 1.92 meter per second. And since you get the value of W, you can easily get the value of V. 1.5 times 1.92 is equal to V. V is equal to 2.89 meter per second. So V is 2.89, W is 1.92, and we are done with that. See, an object of mass 4.2 kilogram is traveling in a straight line at a speed of 6 meters per second. The object is brought to rest in a distance of 0.050 meter by a constant force. Calculate the magnitude of this force. Now, I know that force, I have to use F equals to ma. I have mass, but I do not have acceleration. And the question did not mention that this object is moving with a constant speed. I cannot, because the speed is not constant, because eventually the object is brought to rest. That means V is equal to 0. So I cannot use speed is equal to distance over time. Now, what shall I do? I use one of the kinematics equation, which is V squared equals to U squared plus 2AS. V is equal to 0, U is 6 squared, plus 2A must be negative, times the distance is 0.05. A I got was 360, negative 360 meter per second square. Now F is equal to 4.2 times negative 360, and I got negative 1500 Newton. And beware, the question asks you to calculate only the magnitude. Do not put in the direction. Therefore, the answer must be 1500 Newton. Now, question number 4, define strain. Strain, this is the symbol of strain. It is defined as extension per original length. Is that okay? B, a copper wire of length 4 meter has a uniform cross-sectional area of 4.5 times 10 to the power negative 7 meters square. A tensile force of 18 Newton is applied to the wire. This causes the wire to extend by 1.4 millimeter up to its limit of proportionality. First part, calculate the Young modulus of the wire. So Young modulus, how do you calculate? Young modulus is equal to stress over strain. Stress is equal to force over area. Divide strain extension over original length. So when you modify it, it becomes FL over AX. F is given as 18. Length is given as 4 meter. Area is given as 4.5 times 10 to the power negative 7. Extension, you have to beware because extension is given in millimeter. You have to change it to meter. So 1.4 times 10 to the power negative 3. Calculate, you will get 1.14 times 10 to the power 11 Pascal. 1.14 times 10 to the power 11 Pascal is the answer. The next one, on Fig 4.1, draw a line to show how the stress varies with the strain of the wire up to its limit of proportionality. Remember extension? Remember Young modulus is equal to stress over extension, strain, right? Look at the question. Tensile force, right? Tensile force of 18 Newton is being applied to the wire. And this is a maximum force that could be applied. Now, I need to get the stress. So the stress is equal to force over area, maximum force that will extend the wire up to its up to its limit of proportionality, and divided by the surface area of it, which is 4.5. 4.5 times 10 to the power of negative 7. Use your calculator to calculate 18 times 4.5 times 10 to the power negative 7. You will get 40, or 4 times 10 to the power of 7 Pascal. So this is the maximum stress that the wire could handle. So since I get the stress, I need to find the strain. How to find the strain, right? Because I do not have the, or you want to use Young modulus is equal to stress over strain, which is easier. I use Young modulus as 1.14 times 10 to the power 11 is equal to stress, which is 4 times 10 to the power of 7. Let me write this now. Over strain. So from here, I can find my strain. 4 times 10 to the power 7 over 1.14 times 10 to the power 11. If you do not want to use this, you can use extension over original length. Also can. So 4 times 10 to the power 7 divide 1.14 times 10 to the power 11. And I got 3.5. 3.5 times 10 to the power of negative 4. Yes. So 3.5 times 10 to the power negative 4. So 3.5 is here. So I mark the point, which is here. Now, what am I supposed to do next? Is that take out the ruler, use the ruler. Now I'm going to turn my ruler a bit. And the graph must start from origin. Do you know why? Because if there is no force applied to the wire, then there is no extension of the wire. Move it a bit here. a bit lower, a bit higher. Oh, higher and lower is very hard for me to plot. Now I'll move it a bit lower here. Okay, maybe this one is the best one. Okay, I'm going to use red color to draw. So I just extrapolate. I just draw it. Make sure that you draw on the point. So this is the graph. Now a second copper wire has the same length as the wire in part B, but a larger diameter. Both wires are subjected to a tensile force of 18 Newton. By placing a tick in each row, complete table 4.1 to compare the stress and strain of two wires. I would like to do this because Young modulus is the same. That is why stress is equal to force over surface area. Larger diameter, larger surface area. That is why the stress would be lesser in second wire because second wire has a larger diameter. And since the stress is smaller, Young modulus is stress over strain. Young modulus is constant. Stress is directly proportional to strain. Directly proportional to strain. Stress is now lower, strain must be lesser as well. Question number 5. A stretch string PQ has length 1.2 meter. One end of the string is attached to a vibration generator and the other end is attached to a wall as shown in Fig 5.1. Vibration generator is switched on and a stationary wave is formed on the string. The string is shown at one instant of time in Fig 5.2. A. Explain how a stationary wave is formed between the vibration generator and the wall. You see, first of all, wave will be produced by the vibration generator. So wave will be traveling towards the end, towards the wall. And then since the wall is an opaque material, it will block the wave from going through it. So what happens to the wave? No choice. Wave must be reflected. When the reflected wave is just coming back, it will be superimposed with the incident progressive wave set up by vibration generator, which gives you stationary wave. Now, let me explain on that. First, vibration generator causes string to vibrate at the same frequency. Progressive wave is formed and the wave travels towards the wall and being reflected. So you have to put reflected. So reflected wave superimpose with incident wave at the same speed and same time to form stationary wave. That's it. B, calculate the wavelength of the stationary wave shown in Fig 5.2. By looking at this, I could not guess this is stationary wave unless the question already mentioned this is the stationary wave, right? So how do? I draw out the wave profile of the stationary wave, which is this one. Okay, so I have 3 loops here. One loops represent half lambda, and half lambda. So I have 3.5 lambda. So 3 over 2 lambda is equal to, remember they give us the length of the string PQ, which is equal to 1.2 meter. Lambda is equal to 1.2 times 2 divided by 3. That will give you 0.80 meter. That is your wavelength. Next one, C, Fig 5.3 shows the stationary wave at time t equal to 0 when all points on the wave are at their maximum displacements. The period of the wave is 0.16 second. On Fig 5.3, sketch the shape of the stationary wave at time t equal to 0.24 second. Now I want to say how many waves is being formed, how many wave profile, how many period has passed at the time of 0.24 seconds. So I take 0.24 divided by 0.16 and I got exactly 1.5. So that means 1.5 wave has already formed. So this is one wave and 1.5 wave. So what happens next is that this wave is reaching Q, which is the wall. When the generator, the vibration generator, is just about to send another wave, start from P, this wave will be reflected wave. This wave will be reflected back. So you will see that they will coincide with each other. So this is the one that you have to draw. So I draw it from the front to form a stationary wave. So that's it. Now, D point R and T on the string are a horizontal distance of 0.3 meter apart and in the positions shown in Fig 5.4. State the phase difference between the oscillations of points R and T. Now, for stationary wave, there are two phase differences. One is zero phase difference. The other one is 180 only these two. So how do you see whether this is 180 degrees phase difference or zero phase difference? Now, I will draw my wave first. Okay, I will draw out my horizontal line. And then I will draw out my stationary wave. Okay, I want you to compare the loop. I will highlight. Now, the one that I highlighted. Yeah, if you want to base on the one that I highlighted, that means the green wave profile, you can base on just the green wave profile. To form this wave profile, the green wave profile, all the particles must be oscillating upwards. And to form the green profile, at T, all the particles must be vibrating downwards. Could you see that? Up and down. At R, the particles are oscillating upwards. At T, the particles are oscillating downwards. Up and down are two opposite directions. So that is why the phase difference is equal to 180 degrees. E, calculate the speed of the progressive waves on the stretch string. Speed V equals F lambda. Remember the period is given. So frequency is 1 over period, lambda. This is 0.16, lambda is 0.8. You get 5.0 meter per second is the answer. Question number 6, state Kirchhoff's first law. Kirchhoff's first law is about the current, remember? So I will say for a given junction, total current into the junction equals total current out from the junction. That's it. B, a cell with internal resistance R is connected to two resistors of resistances R1 and R2 as shown in Fig 6.1. Potential differences PDs across R1 and R2 and V1 and V2 respectively. The terminal PD across the cell is V. The current in the circuit is I. Use Kirchhoff's law to show, you have to use Kirchhoff's law, there are two laws, to show that the total resistance RT of the external circuit is given by RT is equal to R1 plus R2. Now, how do we show that? I'm going to use Kirchhoff's second law. How about that? So total EMFs is equal to total PDs. So how many EMF involved? Now, the sources of EMF is that you just look at the battery, look at the cells. Those are the sources of EMF. So I have only V total as my EMF, but the PDs, because I have R1 and R2, so this is PD across R1 and R2, V1 plus V2. By using Ohm's law, V equals to IR. So this is I total, or, oh no, not I total, it's just I because they give us the symbol. I times R total is equal to I R1 plus I R2. So in series, I1 plus I2. The currents are the same, or you can just put currents are the same. Okay, in series, currents are the same. So you can cancel the current. That is why you left RT is equal to R1 plus R2. Done. Now see, the electromotive force, EMF, of the cell in fig 6.1 is 1.5 volt. The values of R1 and R2 are 10 ohm and 15 ohm respectively. Terminal PD of the cell is 1.35 volt. Calculate the internal resistance of the cell. When I want to calculate the internal resistance of a cell, when the internal resistance is not being negligible, the equation that you are supposed to use is EMF is equal to V plus IR. But the problem is, I do not have the value of I. No problem, right? Because the terminal PD of the cell is being given. Use Ohm's law. V equals to IR. V is 1.35. I is the one that you have to find. It's the total I. R is the total R. Since R1 and R2 are being connected in series, so you just add up 10 plus 15. Therefore, I is equal to 1.35 divided by 25, and your I value is 0.054 amperes. Sub into the equation. EMF of the cell is being given as 1.5, V is 1.35, plus I is 0.054 times with the internal resistance. So the internal resistance is 1.5 minus 1.35 divided by 0.054, which gives you 2.78 ohm. 2.78 ohm is my answer. Now D, a resistor of resistance R3 is added to the circuit in fig 6.1 so that the circuit is as shown in fig 6.2. State the change, state and explain the effect, if any, of this change on the current in the cell. Wow, you see that R3 is being connected in parallel to the main circuit, which is R1 and R2. So when you connect a resistor in parallel with the main circuit, you are actually decreasing the total resistance. The total resistance of this whole circuit is decreasing. So when the total resistance of the whole circuit is decreasing, I didn't change the cell. Cell is the same. Therefore, the EMF, the PD of the cell is still the same. What happens to the current? Smaller resistance, less risk. Less risk, more current will flow. So I would say that the current increases. Okay, why? Because the total resistance of circuit decreases and EMF is constant. Now, what about the terminal PD of the cell? You know that terminal PD, you have to use this equation. I will explain. EMF is equal to terminal PD plus the PD across the internal resistance. Since the EMF is constant, and since the current increases, it will increase the total potential, the PD across the internal resistance because the current increases. So the PD across the internal resistance will also increase. But the total PD, which is the EMF, must be constant. Since PD across the internal resistance is increasing, the PD across the cell would have to decrease. So the current is greater, larger PD across the internal resistance, EMF of the cell is constant, therefore the terminal PD of the cell must decrease. That's the answer. Number 7, nuclei of an isotope of copper, Cu, each have 29 protons and 37 neutrons. The isotope is a beta negative emitter. A, state the nuclide notation in the form AZX for this nucleus of copper. So you write down the copper first. What is A? A is the nucleon number. So how do you find A? 29 plus 37. That will give you A. A is the sum of protons and neutrons number. So the A is 66. 66, what about Z? Z is proton. Done. B, the energy spectrum of beta negative radiation emitted by sample of this isotope is shown in fig 7.1. Use 7.1 to explain why other particles apart from beta negative particles must be emitted during this decay. I want you to see this. Look at the kinetic energy of the beta particles. It is varying. Could you see that the kinetic energy is different? right? But the energy of the decay must always be constant, that amount of energy. So but the kinetic energy of the beta particle emitted during this decay varies with a range of values. So that is why there must be another particles, which I call it as antineutrino, must also be emitted during this decay, so that to conserve the total energy of the decay. Now, the second part, state the name of the other particle emitted during the decay of this isotope. I have reviewed the answer in part one, which is antineutrino. That's the answer. So, yeah. And third one, which is the last part, copper isotope decays to an isotope of zinc. Give the radioactive decay equation for this decay. Include the nucleon and proton numbers of all the particles involved. How do you do about this? Just write down 6629 Cu. Decay to give up beta negative. Remember, beta negative is 0, -1. And plus zinc, Zn. And 66 plus 0, you get 66. 29 is equal to 30 minus 1. Because you have to make sure that left-hand side proton number must be equal to right-hand side proton number, the total proton number. And plus with antineutrino. Remember what I told you about the other particles must also be emitted, which is antineutrino. So that's the end of the discussion of this paper. If you face any problems, if you do not understand, please do comment below and please support me by uh, subscribe to my YouTube channel. Thanks for watching and see you in the next video. Bye.